invite our next speaker up, and as someone as myself who's spoken many times in this, I really appreciate her work. Okay, so which one are you? Okay. Okay. Where's our slideshow on this? Probably go to view. Okay. Full screen. Yep. Okay, so continuing on this theme, we now have work on looking at large route leak detection.
Yeah. Hi, my name is Beichuan Zhang. I'm an assistant professor from University of Arizona. Today I'm going to briefly talk about our recent work on automatically detecting large route leaks. The actual work is done by my PhD students Qing and Varun Khare. So by route leak, I really mean the same thing as prefix hijacking. It's just only difference is the intention. So probably it's called by misconfiguration instead of intentional attack. In such an event, network announces prefixes of other networks without appropriate authorization. In this scenario, there are actually three different parties. The prefix owner, which is the supposed destination of the traffic, and the attacker, that's a network that hijack other people's prefix and divert and attract traffic. The third is all the other networks, which are potential source of the traffic. So if a route leak or prefix hijack happens, the victims is really not only the prefix owner, but also the source networks who actually send traffic to the prefix. They also suffer from this route leak. The current practice is, however, only the prefix owner deals with prefix hijacking or route leaks. What happens is, as a prefix owner, I cannot see what happens on the internet because BGP doesn't tell me. So I have to collect information from remote monitors and collect all the routing announcement and get alerts back to my network. Then I process this data. I decide which one is a real attack. Then I take some actions, call up the attacker network or the upstream ISP of the network, try to stop this attack. But the problem of this is the process takes time. In the case of YouTube prefix hijacked by Pakistan Telecom, it took more than 2 hours to stop the attack. So during this time, your data traffic is vulnerable. Whoever sending the traffic to this prefix, the traffic will be diverted and blackhole. So YouTube actually has the outage during that 2 hours. This picture just shows what I said in the previous slide about different parties. While the prefix owner is trying to stop the attack, which takes time, the other networks are still sending your traffic, and that traffic can be diverted to the attacker. So the challenge is really, how do we protect the traffic before the prefix owner is able to stop attack? A straightforward answer is, okay, what if I can identify those false routing announcements and just throw them away? I don't take that false path. I don't send traffic towards the attacker. But as we know, there are a lot of legitimate reasons for prefix to change a region. So if for other network, not the prefix owner, other network, given BGP routing announcement, look at the announcement, it's very difficult to tell whether this region change is legitimate or not. So it's very difficult to do this to catch all the false routing announcement. What we find out is there are some cases that's actually relatively easier to identify, say, with very high confidence, say, okay, this announcement probably, very likely, they are route leaks or hijacks. So that's our goal, is to catch those cases with high confidence and enable ISPs to automatically react to those false routing announcements. The type of routing announcement, the type of false routing announcement we are going after is as following. So sometimes a network, they hijack prefix of multiple other networks at the same time. And this is typical route leaks. Someone misconfigured their routers, announce other people's prefixes. In the extreme case, that is someone leaked the whole table, and that usually triggered a discussion on NANOGE or other operator list. Our goal of this work is to automatically detect this instance. So those extreme cases, leaking a full table, that's trivial. But we are trying to detect those not extreme cases that leaks just very small part of the table. We want to automatically detect this without help from prefix owner. So there's no need to, there's no requirement from any authoritative information from prefix owner. And we try to minimize the false positives. So all of this is trying to make to enable ISP to have possible automatic response to those false routing announcements. So how we do that? The basic observation is if one AS hijacks a prefix of a single other AS, it's very hard to say whether that's legit or not. However, if one AS at the same time hijacks multiple prefixes that belongs to many different networks at the same time, then we say it's very likely to be a hijack and a leak. Our basic approach is get all the region changes from BGP data and filter out those probably legit changes and remaining set of suspicious routing announcement. Then we look at whether that's the case of a single AS simultaneously hijack prefixes belonging to multiple other networks. First, we process BGP raw data to get all the region changes. However, there are way too many region changes if you look at all the BGP data. And most of them are actually legit changes. So we use the following 5 criteria to filter out those possible legit changes, legit region changes. For example, the first one, if AS has announced this prefix for more than 1 day in the past year, we say, okay, that's possible, that's a legit change announcement, so we don't consider that suspicious. Or if the AS has announced the super prefix of that one for more than 1 day in the past year, or the AS is a stable neighbor of the true origin of the AS, or the whois says, okay, the old and new origin, they are the same organization. So we pass that. And we also found there's a lot of origin changes associated with exchange point. So we filter out all the exchange point prefixes. And this will get rid of most of the origin changes. This filtering is not perfect. It just try to reduce the noise in our final result. Because remember, our goal is not to catch all the hijacks. We are trying to catch a small number of hijacks with very, very high confidence. So after the previous filtering, if AS still announces prefixes that normally announced by other networks, we say, okay, this AS is offending another network. And how many networks is offending, we call that number as an offense number. In the most case, the offense number is just 1 or 2. But there are a small number of cases, the offense number is pretty high. And we set a threshold of 10 to say if you are offending 10 or more other networks, then we say this is a route leak or prefix hijack. This figure gives you the distribution of the offense value from 2009 data. So it's a whole year of data from Routeville, Oregon collectors. You can see the x-axis is offense value, how many networks you are offending. And y-axis is the number of events with this offense value. You can see most of the events, they have offense value 1 or 2. But there's a long tail over there, and we cut the threshold at 10. So apply this simple algorithm to the data from Routeville, Oregon collector, 7 years of data. We detected every year 5 to 20 events, route leak events. Now let's see how accurate or useful is this information. In order to verify the result, because we detect this without any authoritative information from prefix owner or any other source. So we actually send a lot of emails to victim networks, try to confirm these events. And the result is very positive. For all the events, 9 events in 2009 and 6 events in 2008, all of them have been positively confirmed by victim networks as route leaks or prefix hijack. We didn't send emails about the early years because probably that's too old and operators won't have the patience to dig out their record. But for these 15 events we send emails about, they are all positively confirmed. One comment people about this usually is, hey, it's large route leak, so we all know about it. But actually that's not the case. What we know from the NANOGE discussion or other operator list is usually is a full table leak. So out of these 15 events, we only found 1 event on the NANOGE list, and that is a full table leak in 2008 by a Russian ISP. All the other 14 events, we didn't find it in NANOGE or other APNIC or any other operator mailing list. So basically, most of people are not aware of that. Some of the prefix owners, they knew about those route leaks or attacks when we talked to them through emails. But many of them didn't know that. When we send this email, they say, hey, this is my prefix. Someone announces, I'm glad you found this out. How do you do that? So basically this says, even though we are now trying to catch all the prefix hijacks or route leaks, still the information, the things we can catch is still very useful, non-trivial, and potentially very useful to operators. This is just a list of all the 9 events we detected in 2009. The last column is where the attacker network is: Saudi Arabia, Nigeria, Argentina, Romania, Russia, Indonesia, all over the world. The third column is offense value. That is how many other networks this attacker is hijacking. We can see none of this is full table leak. They usually just hijack prefixes belong to like tens of other networks. And look at the duration. Some of them are very short, like 1 minute or 2 minutes. Probably that's fat fingers. But a few of them last a few hours, 2 hours, 10 hours, or 8 hours. So some of them really could cause a significant outage. There's one case study we learned from emails with operator that is on February 14th, 2009, there's a AS 8895, that's a Saudi Arabia ISP, announced a prefix belonging to other 34 local ISPs or local networks. And this is a kind of a global event because 41 out of 43 route view monitors see this route leak. So it affects basically everywhere, almost everywhere on the internet. And this is a confirmed event. So what we learned is actually 8895 was the provider of most of these smaller local ISPs, but those ISPs actually switched to another ISP. So, but due to a misconfiguration, 8895 announced a prefix of these ex-customers. That's what happened. Okay, and this is the offense value of 8895 in 2009. Most of the year, this only showed like the 2 hours during the event, but the rest of the year, the offense value is almost 0. So only this 2 hours, all of a sudden you see the offense events jump to 20 or 30. And this is a distribution of the duration of the route leak events, of all the events we detected. We can see, so x-axis is the duration in hours, y-axis is the CDF. Most of them are short, but still the upper 20% can last more than 3 hours. And the number of prefixes offended, this is distribution. The median is 76. So on average, each outleak hijacks like 70, 80 prefixes. And what's the impact on the internet? This is percentage of route view monitors that detect those events. Because 80% of these events actually are observed by more than 60% of the monitors. So they are impacting a significant part of the internet. This work has the same goal as a pretty good BGP of protecting data traffic by non-prefix owner network. But we have different approaches. Pretty good BGP block all the new origin announcements, so they can catch all the prefix hijack. But at the same time, you're going to have many, many false positives. We are not trying to catch all of them. We are trying to catch a small number of them, but with very high confidence. As our result shows, all the 15 events we have tried to confirm have been confirmed positively, and the operators send us very positive feedbacks. So by this, because the result is with high confidence, so hopefully can enable some automatic reaction. There are two potential deployment scenarios. One is individual network can run this in their network and get the real BGP feed from your border router and run this algorithm, detect whether there's a route leak going on. If it is, drop the false routing announcement. You could set a high threshold. In this work, we set a threshold at 10. You could set a higher threshold for automatic response. Or you could have also lower threshold, say, okay, if it's 5, then I want to take a look. If it's 20 or 100, I want the router automatically drop the announcement. Another deployment scenario is to incorporate into monitoring system like Cyclops, so the users not only get alerts about their prefix, but also get alerts about ongoing route leaks. And we have some ongoing work about improving the algorithm and running this on real time and incorporate it into Cyclops. So that's it. Questions?
Do we have any questions? Okay, thank you very much.